Hi everyone, more problems on AP Calculus review. So this one, it's going to be two problems. First one is a piecewise function. And like you see here, this example, it said this is a piecewise function, so it continues from two parts. The first part, minus x squared plus 3, when x less than or equal to 5. Second part, 10x plus 2 plus 20, when x equal to 5. So how we know if the function, the piecewise function, continuous and differentiable. So the rule is if the limit when x approaches, so the number here is 5 from the negative, or from the left, f of x equal to the limit when x approaches 5 from the right, f of x. So that's what we're going to try to prove. To prove is the limits for the function when we approach from the left of the 5 is equal to the limit of the function when we approach to the 5 from the right, right? Okay, so let's try limit when x approaches 5 from the left, f of x, which is equal to the limit. So we're going to use the first one because this is from the left, that's a negative, so this is x less than or equal 5. So that's going to be the first equation, which is going to be minus 5 squared plus 3. Minus 5 squared is minus 25 plus 3, so that's equal minus 22. Okay, so that's first value. Then the limit when x approaches 5 from the right. Which equation we're going to use? We're going to use the second equation because x is greater than 5. So it would be minus 10 x5 is equal to plus 28. So it will be equal minus 50 plus 28, which is equal minus 22. So it's a good sign. So that's the second one. Then let's try when at x equal 5, which is going to be the same, the first equation, not minus 5 squared plus 3, which is equal to minus 25 plus 3, which is minus 22. Okay, so now we know that limit when x approaches 5 from the left is equal to the limit when x approaches 5 from the right is equal to the limit x equal 5 is equal to minus 22. So that being said, that means f, which is a function, is continuous and differentiable at x equal 5. Okay, so that's how we know that the function is differentiable, continuous and differentiable. Okay, let's take another problem here. The second problem is said f dy over dx is equal to 2 minus y. Okay, and it said if y equal 1 when x equal 1, then what is the y? So he wants to know what is the y here. The y of the equation. Okay, let's see. So first we're going to take the integration for both sides. So integration, we want to get the x's on one side and the y's on one side. So we can say, we're going to just kind of bring the 2 minus y here and bring the dx here. It's just replace. So we say dy over 2 minus y equal dx. That's exactly the same like this one. We didn't do anything, okay? So let's put in, so normal layout. So dx is equal to 1 over 2 minus y dy. Okay? So that's the equation we're going to work on. So let's take that integration for both sides, right? Okay, integration. So integration of dx is x. Integration of 1 over 2 minus y, right? So let's explain this one. So we can say integration is 1 over 2 minus y dy is equal. We can say that natural log, we want to make it like y minus 2. So we can say natural log minus natural log of y minus 2. So that's the integration. We replaced with multiply by negative. So we want to get the y by itself here. So let's substitute here in this equation. So that will be minus natural log of y minus 2 plus c. Okay? So multiply both sides by negative. So it will be negative x is equal to natural log y minus 2 minus c. Okay, so minus x plus c is equal to natural log of y minus 2. So natural log of y minus 2. So we want to get the y here. So what we do to get, we use the exponential function. So we use the e to the x function to basically get rid of this natural log, and we'll be able to isolate the y by itself, right? Okay, so let's apply this. So we're going to say e to the natural log y minus 2 is equal to e to the negative x plus c. So e to the natural log, that's mean y minus 2 is equal to e to the minus x plus c. Okay, so that's exactly the same like y minus 2 is equal e to the minus x times e to the c, right? It's exactly the same. So we can say here, so we add 2 to both sides, so it will be y equals 2 plus e to the c. It's the same like e to the natural log, so e to the c is equal to c, right? Okay, so it will be c e to the minus x. And then it's given, he said, when x equal 1, y equal 1. Right? So let's substitute. So 1 equal 2 plus c e to the negative 1. So it will be 1 equal to c over e. Right? E to the negative 1, we bring it to the denominator. So it will be e. Right. Let's now get the c. We want to try to get the c. All right? So 1 minus 2, subtract 2 from both sides, equals c over e. So that would be negative 1 is equal to c over e. So multiply, so c is equal to negative e. Okay, c is equal to negative e. Now let's substitute back to the equation for the y. Y equal 2 plus, so y equal 2 minus, c is minus e, so minus e times e to the negative x, right? So y will be equal 2 minus e. Here is 1 exponent 1, so 1 minus x. So, and that's gonna be my equation here for the y he's asking for. So y equal minus e to the 1 minus x.